Greetings and welcome to my new calculus channel. My name is John Gabriel. Uh, the problems I discussed in the previous video with academics like Gilbert Strang and his foolish colleagues at MIT, um, 0 over 0, effectively 0 over 0, you know, he said something to the effect that dy over dx is effectively 0 over 0, which is total garbage, of course. And students never really understand. All they do is they pick up on the results and they simply use the results. And of course, how can they understand? Their moronic lecturers and teachers don't understand. Therefore, students lose interest after a while. They drop out of STEM courses because they don't understand the most important concept in mathematics. It's the concept of number. I can't stress enough, I can't overemphasize how important is the number concept. Euclid and the ancient Greeks spent or wrote 6 chapters before they defined number in book 7. And in those first 6 chapters, they defined all the arithmetic operations, not with numbers, with ratios of magnitudes. A magnitude can be anything. It can be a line segment, it can be an area, it can be a mass. It isn't a number. So a number is a name that we give to describe the measure of a ratio of magnitudes. Very, very important to understand that concept. Most important. So let's continue. Most teenagers will have a reasonable idea of what a number is. There will be those who still have issues, such, as those who claim that negative numbers don't relate to anything in the real world, and also the problematic 0. But to be precise, we need to look at these two concepts carefully, okay? So, is there such a thing as a negative number? In reality, there isn't. Not even in abstract theory is there such a thing as a negative number. And it only takes meaning, it only acquires meaning in the physical world, because a negative number usually has an extra attribute attached to it. In other words, not just a name that's given to the measure of a ratio of magnitudes, but it indicates a direction. So in a sense, a negative number is almost like a vector, okay? Like the beginning, the first part of a vector definition, because what it does is it indicates that we might have a shortfall of k, or a lack of k, or a need of k, and that's all it does. But the minus that appears in front of the k doesn't change the fact that k is a number, okay? Can be any number, any rational number, with rational being redundant, because there is no such thing as any rational number or a real number. Those are both bogus concepts. So, as I said, it's hard for students to grasp the concept because they're introduced to the concept via a number line. And this is never properly explained. I mean, I remember I was at school too once upon a time, and my teachers were morons. They didn't understand. They couldn't explain. And this is the case, unfortunately, in most parts of the world. So there are no negative numbers, only distances in a different direction from a specified origin. And when we put the minus sign in front, that's all it indicates, okay? So that's why we can say, okay, it makes sense almost to call them negative numbers because they have that extra attribute. But one could also say, well, ordinary numbers have that extra attribute too, because there's a default positive sign in front of a number, right? So those operators become unary operators, okay? In other words, they act to add an extra attribute to number. So 0 is a much bigger problem because in sound mathematics, 0 is not a number of any kind, okay? It's not a measure of any ratio of magnitudes. So to be a number, one must first have a ratio of magnitudes. So let this be the ratio of magnitudes. Okay. A number is what we get when we measure these aliquot parts of the ratio using a common divisor. The Greeks first called this thing quotientness. There's no, that English word is just a word I made up for the Greek one, for which there is no English equivalent. The Greek word is pilikotita, okay, and it means quotientness. So a ratio has quotientness if and only if its aliquot parts can be measured by the same magnitude. Okay, now in geometry, all ratio arithmetic is 100% accurate. But in algebra, we're not just looking at measure through a geometric unit. In other words, if we wanted to measure this unit, using this unit, we could simply take a divider like that and say, oop, there you go. All we need is this part of this unit, right? Or this magnitude. We only need that part. So for example, if you had square root 2, something like that, you would need one of these and just a little bit of the unit to complete the measure. It's 100% accurate, okay? But it's not the case. It's not the case in algebra where we use an abstract unit whose size and type are irrelevant, okay? Totally irrelevant. So a ratio is where we get the first idea of number, okay? And when we measure the ratio, we end up with numbers. But I've already talked a lot about that in previous videos. I've got lots of articles written on the subject, so you can read up on those. Now, zero serves two purposes in mathematics. Zero helps to communicate other numbers, and its primary role is placeholder. So let's take a look at that example. So if you wanted to communicate, let's see what this number is, 10,902. You couldn't write that because that wouldn't be correct, would it? Now, if you had a template, let's say you just had a radix template and you had units, tens, hundreds, thousands, and 10,000s. 10,000s, okay? Then you could say, okay, we need two of those. We need 9 of these. And we need one of these. Okay, so that's 10,000. Let's see if I got that. I'm sorry. The 9 comes under the hundreds. Okay, so we wouldn't need zero at all. Can you see that? And we don't have to write these using zero. We can say units, tens, hundreds, thousands. It means the same thing, right? So zero is not needed at all in mathematics, but it makes the job of doing mathematics a heck of a lot easier. Imagine if you wanted to communicate 10,902 to your friend. You'd have to carry your radix template around with you all the time so that you could just put the digits in the columns. And you'd have to have a special board where you can erase them so that you could communicate different numbers. You don't need zero at all in mathematics. It has no other role except an auxiliary role. It's very useful in that role. Okay. So coming back to what I was talking about, zero helps to eliminate ambiguity. Okay. Zero means by itself means no number. Okay. Zero means no number. Now, get a grasp of this because you probably don't know this, but had the brilliant ancient Greeks accepted the concept of zero as a number, you wouldn't even be able to do the most basic arithmetic with fractions. You wouldn't have a clue, by the way, because the ancient Greeks had a calculator which people could use who didn't know anything about number or even anything about arithmetic, and that calculator yielded 100% accurate results for all the 4 basic operations. Okay, difference, sum, quotient, and product in that order. And these were all formulated in book 5 of the elements using magnitudes. There weren't even any numbers there. It was all geometrical. Okay, but all of this was transferred intact to algebra. All of it. There's not even a single change. The only difference is that algebra uses an abstract unit and that geometry uses a physical unit. Okay, so in algebra, we have to sacrifice precision for generality. Okay, that's the difference between geometry and algebra. The main difference, the abstract unit. So 0 acts also as a placeholder in equations. So if we had this equation here, x minus 3 is equal to 0, it's more meaningful than writing x minus 3 equals with nothing on that side, or with a question mark or whatever, or a little square block like you introduced in your early math classes. So again here, 0 is not a number, okay? Not a number of any kind. It's just a placeholder saying that we want to know what number minus 3 will result in no number, okay? That's the correct way of thinking about it. So finally, a result of 0 can indicate certain conditions. For example, in advanced mathematics, if the curl of a vector field is the 0 vector, then the field is conservative. And there are many other cases where 0 is used to indicate other conditions. Okay, in parallelism, in flux integrals, in line integrals, and in lots of other equations. Even in matrix algebra, you have a great use of 0. So I'm not dissing 0 and saying it's not useful. It's very useful, but it's not a number, and students should be told this. Why should they be told this? Because we don't want to do what Gilbert Strang did in his lecture, do we? We don't want to say dy over dx is effectively 0 over 0, because 0 over 0 is meaningless garbage, okay? If you have a fraction like that, 0 cannot be any parts of this fraction. You can get away by putting a 0 in p, because that's the same as just discarding the whole fraction. But 0 is not a part of a fraction, and all numbers are fractions. There are no other numbers. Pi, the constant that you know about, is not a number. There is no number pi. There's only a constant pi, okay? And it's a rational number, the constant. It's never anything but a rational number. Same thing with square root 2, right? So those are not numbers. Square root 2 and pi, well, actually, as constants, they are numbers. But if you try to measure circumference of a circle with diameter, this measure fails. There is no measure of this. You cannot have a number which will tell you how this diameter can be measured with the abstract unit, and this circle circumference can be measured with the abstract unit. So that means you can't have C over D. It's actually wrong to write C over D, because that means if you write C over D, what does it mean? Let's just see quickly. Reset the canvas. So if you write C over D, that means you've succeeded in measuring circle circumference to diameter. That's false. It cannot go from ratio CD to number CD, okay? That's just not possible. Well, I'm out of breath now, so I'm going to leave it at that. You can become a subscriber if you're not one already. Follow me on academia. Tell your friends about this. If you have a few dollars to donate, I could probably use those for a surgery, as right now I'm at the mercy of people who don't really care about me. So donate if you can. If you can't, that's okay too. My name is John Gabriel, and this is a New Calculus channel. Till next time, goodbye.